To continue with our lesson, now I'm going to give you a summary of everything that you have to know about a circular geometry or Euclidean geometry. So we have this norm to say, let's something to summarize everything. Just says Dr. Cape Town, which is D, R, C, P, and T. Okay. In D is a diameter. Then you have radius. In radius, I'll also include a chord and a secant. Then here we give a cyclic, quad. Then here we have parallel lines. Then here we have a tangent. So here I'm going to list each and everything that is related to diameter. Everything that has to know about what you call a diameter. Okay, now we are okay. We know that a diameter subtend what? A 90-degree angle. So this is also a symbol of a what? Of an angle at center. Because here is the angle at center, then here is, you say angle at center is 2 times the angle at circumference, meaning this is 180 degrees, then here is what? Here is 90 degrees. And they're subtended by what? By a diameter. You can also reason to say it's the angle at center. Then we know that a diameter is perpendicular to it, to a tangent. And mind you, you must know that the diameter doesn't bisect the diameter. It just perpendicular to the diameter. Then another thing is that a diameter is, you must know that a diameter is a line that touches the circumference twice and passes through a center. So if you are given this diagram, here they told you it's a tangent, but they didn't specify or didn't tell you that this is a diameter. Never assume that is a diameter. Because in Euclidean geometry or in a circular geometry, we always say never assume. Because they will always indicate that the diagrams are not drawn into a scale. So you must also bear in mind that you have to be told in everything so that you can always be in a right route. Then now we are moving to what? To a radius. In radius, one thing I told you about is what? A line, which I said a line drawn from center to a midpoint of a chord or perpendicular to a chord is what? It bisects the chord. Mind you, it might come in this fashion. You must also always know. You have to know that in mathematics, not everything will come in the exact way we have taught you. They will just bring it in a different angle so that you can get confused, or in a very congested, many lines that are very useless. So that focus on the concept and the context that we have given you. Then we have what? Angle at center, which comes in many ways. It's a concave type. We have an equilateral, which is this one, and this is x, this is 2x. Then we have this one, which is x, 2x. Then we have another one, which is this one, 2x and x. And remember that in angular center, I said the 3 vertices must be at a circumference. Always must be at what? At a circumference. 1, 2, 3, 1, 2, 3. And one must be at center. So that angle at center is what it can be applicable. So one thing that I will add is angles that are subtended by equal chords. So we say angles that are subtended by equal chords are what? Are equal. And because I said I'll also include a chord, I'll also say angles that are subtended by the same chord or arc are equal. This angle means sometimes they can add a chord, sometimes they cannot add a chord. Just leave it as an arc. Means this equals to this one. Okay? Then let's proceed to what you call a cyclic quad. I said the cyclic quad is an equilateral. That's it. That is inside what? Inside a circle. And I said opposite angles are supplementary. Means x plus 1 is equals to 180 degrees. Then another thing, we'll add what? We'll add an exterior angle of a cyclic quad, which is this one. We say the exterior angle of a cyclic quad is equal to an opposite interior angle. This is what? Exterior angle of a what? Of a cyclic. Of a cyclic quad. Then mind, you must also account that if the extended line is drawn like this, this can never be an exterior angle. An exterior angle must be an extended line. And means the exterior angle, this angle that is outside the equilateral, is equal to the opposite interior angle. Then again, I'll repeat what? A bow tie. Where all the four vertices are what? Are extended. I said this angle equal to this angle and this one equal to this one. I said even if there is no, this shape is not enclosed, you must know that this is a cyclic quad. Means this is also another form of proving what? Of proving a cyclic quad. It's angles that angles in the same segment, or angles that are subtended by the same arc or the same chord. Then now we are moving to what? To parallel lines. And in parallel lines, we always say mathematics is very fun. Mathematics is what? Is fun. Remember, we are talking about parallel lines. Means this must be parallel to this one. And this F shape, we continue with our lesson. Now we are going to parallel lines. When we say mathematics is fun. Then you have what you call a F shape, which symbolize corresponding angles. So some can ask, which are corresponding angles? Corresponding angles is this one and this one. We must know that corresponding angles, we only have corresponding angles if and only if these two lines are parallel to each other. So even if you are giving a reason, you must be able to say C, D. These are corresponding angles because A, B is parallel to what? To D, C. So if these two lines are not parallel, there is no what? Corresponding angles. So even if you are giving a reason, you must include that these two lines are what? Are parallel. So another way to just memorize it and to know is that the two angles must be below or above the what? We can do it like this. You must always know that the angles must either be under the F shape or under the parallel lines, or can be above. Means this angle, if you extend this line, this angle will be equal to this angle. Now is this F that is facing this side. The F starts here. This angle is here, and this angle is here. You must know that under what? Under the parallel lines or above the parallel. They must always be on the same side of the what? Of the parallel lines. Now we move on. We have what to call what? A U shape. This U shape just symbolizes what? The core interior angles. Everything is in the name. Core means two. Means you're hearing about these two angles. And interior means what? Inside. Inside the what? Inside the parallel lines. Even these two, you must include or you must elaborate or say that these two lines must be what? Parallel to each other. Meaning we have co-interior angles only if these two lines are what? Are parallel to one another. So we say co-interior angles, they are supplementary. Means they add up to what? They add up to 180. Then move to the last one, which we call what? An alternate angle or alternate angles. Then we say they form a N shape, or you can say they form a Z shape. Means that this angle is equal to this angle. This angle is equal to what? Is equal to this angle. Mind you, I will also repeat, only if these two lines are what? Are parallel to one another. Meaning, even when you are writing your reason, you must show we have alternate angles if AB is parallel to what? To CD. Okay, now we finish that. The kinetics is fine. We're going to what? We're going to tangents. Okay, we can say more. We say a diameter is perpendicular to what? To a tangent. A tangent and a diameter. Then we say, otherwise we know diameter is 2 radius. It's 2 radius. Means the radius is also perpendicular to what? To a tangent. Then we have what we call a tangent, which I explained earlier on. I said the angle that is between the tangent and the chord is equal to the same angle that is opposite to the same one, to the same chord. I only symbolize with the what? With a leg, the chord. The tangent and the chord. Where the snake bites is where that angle that is formed there is equal to the angle that is between what? Is between a tangent and a chord. Okay. Let me say this angle is equal to this angle. You see the tangent, the chord, opposite to the chord, it equals to the one. Then we have another one. We say the tangents that are from what? From the same point are equal. In most cases, when they present in equation, you find that maybe there is a chord here. If there is a chord, it means this is another type of what? Is another type of a triangle. You know, we have different types of triangle. We have a scalene, we have an equilateral, we have isosceles triangle. Then you know, if you want to find these two angles, you will say angles facing what? Facing opposite equal angles. Then if now you have to find side, you say if these angles are equal, you say sides facing opposite what? Opposite angles. Thank God.